This is a good place to do a review for solving rational inequalities. We already looked at this in week 1 when we first talked about inequalities. So the argument here, a rational expression. We know that the argument has to be greater than 0. And we always want the right side of our inequality to be 0. We're going to find the real zeros of the numerator and the denominator. Now I know because this is greater than, not greater than or equal, I know that the numerator cannot equal 0. And I'm just going to write that here to remind myself. I know that the denominator can never equal 0. Next, we place the real zeros on a number line. These are our critical numbers. They help create the intervals that we want to look at. We're going to use an open circle for the numbers that are equal. We're going to use a closed circle for the not equal. Both of these are not equal. I just wrote that backwards. Open circle, not equal. Closed, equal. I hope you all noticed that and didn't copy the mistake. Open circles for both of these because they are not equal. We've created 3 intervals. We have an interval from -infinity to -1, an interval from -1 to +1, and another interval from 1 to infinity. These are all open intervals because of our real zeros are not permitted. We're going to choose any value for the interval. So remember, it doesn't matter what you choose. In this interval, I could say x equals -2. I always like to use 0 if possible. Don't use the endpoints. We never use those endpoints. We use some other number in the interval. So we're choosing some value for x in the interval, not the endpoints. And remember, now we want to just substitute x into the expression. And all we're interested in is whether or not the expression is positive or negative. We don't really care what it equals. So I had in my expression in the numerator, it was 1 plus x, and in the denominator, 1 minus x. I'm just going to write them here, 1 plus x, 1 minus x, and then the whole function. What was this function called? R of x. All right, when I substitute in -2, I have 1 plus -2, which is -1. And here I have 1 minus -2. So I have a negative over a positive. That means my whole function here would be negative. Why don't you substitute in x equals 0 and x equals 2 and determine whether the interval is positive or negative? So you should have found that the middle interval was positive and the final interval is negative. Remember that the argument has to be greater than 0. We're looking for the positive interval. So our solution here then for the domain of this rational function is in the interval -1 to +1. If you want more practice, go back to the week 1 lecture, Solving Rational Inequalities.